Here's section 7.2, exercise 56. Now this is interesting. We're told we have, we're considering the solid of a region bounded by y equals the square root of x, y equals 0, and x equals 4. And we're going to go around the x-axis. So square root of x does something like that. Y equals 0 is the x-axis. X equals 4. Comes out here, so that's a 2, and that's a 4. And so we're going to revolve this around the x-axis, so we're slicing like that. Okay. And what we're asked to do is find the values of x in the interval 0 to 4 that would cut this thing into thirds. Okay. Well, I don't know. I think probably the way I go about this is I think I'd just go ahead and find the answer first of that volume. So here our radius is just the y value squared, so our r is just x. That's nice. And we're going from 0 to 4. So I have the integral, pi times the integral from 0 to 4 of x dx. So that's not bad. Pi x squared over 2 from 0 to 4. And so I get 16 over 2, or 8 pi. Now, so what that tells me is I want to find an x value such that, now I don't have to call it x, I can just call it a. And what I want to do is find a so that the integral from 0 to a of pi times x dx is equal to 8 pi over 3, because that would be splitting it into thirds. And so, okay, I already know the antiderivative here is pi x squared over 2. So I have pi x squared over 2 from 0 to a. I want that to be equal to 8 pi over 3. So 0 is fine. I get pi a squared over 2 is equal to 8 pi over 3. Well, I can multiply both sides by 2 and divide both sides by pi, and so I get a squared is equal to 16 over 3, and so a is equal to 4 over the square root of 3. Okay, so that's a. And that number 4 over the square root of 3, what the heck is that? Well, good question. Square root of 3 is like 1.7. It might be easier to think about it if we write it as, if I multiply top and bottom by the square root of 3, so I've got 4 times the square root of 3 over 3. The root of 4 times 1.7 is like, what, 6.28? So this is about 6.28 over 3, and so that's what, 2.09, or about 2.1. So this is somewhere around 2.1. Okay, so that's A. Now I need to find B. And I can go about B a couple different ways. I could either insist that the integral from my A, so 4 over the square root of 3, to B of pi x dx is equal to 8 pi over 3. Or I could insist that the integral from b to, what are we going to? 4 of pi x dx is equal to 8 pi over 3. Now, since I know that the 4 is going to make an 8 pi, I think I want to go that direction. So I'm going to use this one. And so I have the integral pi x from b to 4 dx. And that is my pi x squared over 2 from b to 4. Now the 4, I know I get 8 pi, and then minus pi b squared over 2. It needs to be equal to 8 pi over 3. So that means subtracting 8 pi from both sides, I get 16 pi over 3. Sorry, negative. Sorry, I'm writing this poorly for you. Minus pi b squared over 2 is equal to a minus 16 pi over 3. I make those plus. Divide both sides by pi. And multiply both sides by 2. And we get that b squared is 32 over 3. And so b is the square root of 32 or square root of 3. Now, square root of 32, well, 32 is 16 times 2. So this is 4 times the square root of 2 over the square root of 3. And once again, I could multiply, top and bottom by the square root of 3. And so you get 4/3 times the square root of 6. Okay, square root of 6, I don't know what the heck that is. 2 point something or other. Good question. What is it? Maybe like 2.5-ish, right? Because 25 times 25 is, I think, isn't that like 625? You people are supposed to chime in and tell me on this video recording. So I think it's like, somewhere around 2.4 something. So call it 2.5-ish. 4 times 2.5 is 10. This is like 3 1/3. So this is somewhere around, maybe 3.3, something like that. And as you, look at what it ought to be, right? We got an answer first around 2.1 and then around 3.3. That looks reasonable, right? Because I went more than halfway to get to A. And then I went more than halfway from A to 4 to get to B, and got that. Okay, now another way to check is that, remember this integral from 4 over the square root of 3 to B. Well, now we're saying B is 4 times the square root of 2 over the square root of 3. And so if I have 4 over the square root of 3 and 4 over the square root of 3 times the square root of 2, that's one way to look at that, of my pi times x dx, right? That's pi x squared over 2, 4 over the square root of 3, and 4 over the square root of 3 times the square root of 2. Now, when you do that, I get to factor out the pi over 2, and then I'll have that x squared, but notice that's um, uh, 16 over 3 times 2, and then minus 16 over 3. And so that's just 16 over 3. And so I get 16 pi over 2 times 3, but that's just 8 pi over 3, which is what I'm supposed to get. So yes, I'm pretty sure we've got the right answers here. Okay, so we go from 0 to 4 over the square root of 3. Then well, like that, I guess. Then we go from 4 over the square root of 3 to 4 over the square root of 3 times the square root of 2. And then we go from 4 over the square root of 3 times the square root of 2 up to 4. And those 3 intervals then would split our volume into thirds. So a bit involved, and a nice way to do some algebra. But yeah, we can do algebra with our unknown being like up there. That's fine, or down there, doesn't matter. We just go through it, and then we solve for it once we've evaluated everything. So there we have number 56.